So what does the problem statement state? It states that there are n cities and some of them are connected and while some are not. Okay. And if a city A is connected to city B and city B is connected to city C, then we can say that A is indirectly connected to city C. Province, what is a province? It is a group of indirectly or directly connected cities. We are given a n cross n matrix is connected, which tells if is connected of ij equals to 1. That means the city I and that city j are connected, right? And we have to return the number of provinces. What the question is saying that we have a matrix and here I have a 1 and here I have a 1. So rest I have zeros, right? So it is telling us that city 1 is connected to city 0 and city 1 is also connected to city 2. So we can see all the three cities are connected. So the number of provinces is 1, right? This is what it is saying. And for example, if I have something like this, city 1 is connected to city 2, city 3 is connected to city 4, and city 5 is connected to city 2. So how many number of provinces are there? There are two number of provinces. One is this one, and other one is this one. So we have two number of provinces, and so in the end we have to return a 2, right? So let us just take a example and we will solve it. So for example, I have a city 1 that connects to 2. So this is our example and the corresponding matrix for this will be. So here we have a number of cities. And now let us just fill it. So 1 is connected to 2, 1 is connected to 2, 2 is connected to 3, 2 is connected to 3, 4 is connected to 5. 4 is connected to 5. So they are undirected edges. So if 4 is connected to 5, then 5 is also connected to 4. If 2 is connected to 3, then 3 is also connected to 2. And if 1 is connected to 2, then 2 is also connected to 1. Rest are 0. This is what we have, and we can ignore this because the numbering of our cities is from 1 to n inclusive. So we can ignore the 0th row and 0th column. So now how we will do this? What we have to do is, first of all, we will form this adjacency list. Then okay, so in the adjacency list what we have to do is, like, a city 1 will never connect to city 1, right? That is one condition we have to look after. And if it is connected, so if this connected of ij is 1, then we will form a city, right? So this is the condition while we will be making our adjacency list. Now after that, what we will be doing, we will be doing a simple DFS on our graph. We can use a BFS also, but we will use a simple DFS and we will loop through my adjacency list from 1 to n. And on each iteration, I will do a count plus plus, right? If visited, if it is not visited, then I'll do a count plus plus, right? Now let us just go forward with the example. Now I have 1, I have 2, I have 3, 4, and 5. This is a graph I have. Now I start from here and I'll make a vector visited 0, 1, 2, 3, 4, 5, and initially each of them is not visited, so I'll mark them as 0. Okay, I move through, I check, okay, 1, I see, okay, the visited of 1 is, I see the visited of 1 is 0, so that means 1 is not visited. So what I will do, I will mark 1 as visited. Uh, then I'll move forward and I'll call the DFS on 1. Then I'll go ahead, I check, okay, the adjacent of 1 is 2. I check if is 2 visited. No, 2 is not visited. So I move to 2 and I mark 2 as visited again. Okay, the 2's adjacent I have 1 as well as 3. I can't move to 1 because it is already visited. So I move to 3 and I mark it as visited, right? Then I come to 3. Okay, 3's adjacent is 2. It is already visited. So I go back. 2, it has visited all its neighbors, so I go back. And 1, it has visited all its neighbor, I go back. Now in the for loop I have initially, it will be something like this, right? I plus plus. So it will be something like this. So then I have done it for 1. Now I go to 2, I goes to 2. I see, okay, 2 is visited, I will not go. 3 is visited, I will not go. I'll directly come to 4. Now same thing will happen for 4 and then we can move forward. So I'll just code it and then it will be completely easy as it is a simple DFS, but we just have to do a count plus plus when we have not visited that. So let us just move to the code part.
Okay, so here I am on the lead code ID. So let me just name change the name of this to is con, right? And I'll get the size. So is int former adjacency list. So vector of int adj of size n plus 1. Why I'm taking n plus 1? Because the numbering of my cities is from 1 to n, not from 0, so I have to take one extra. Now I'll form this. So for int of I equals to 0, I less than n, I plus plus, I will traverse my iscon. For int of j equals to 0, j less than n, and j plus plus. Now I'll check if con of I j equals to 1, and at the same time I is not equal to j, because the same cities will not connect to each other. Now if that is the case, I will do a adj of I plus 1 pushback j plus 1, since my cities starts from 1 to n, not from 0, so that is why I'm doing this. Now I'll do a dfs. For that I need a visited array, so vector of int visited, it will be of same size n plus 1. I'll take a variable count, so int count equals to 0. Now I'll traverse for all the edges if there can be some disconnected components in the graph. So int I equals to 1, I less than equals to n, and I plus plus. If not visited of I, then first of all I'll do a count plus plus. After that I'll call it dfs on I with passing my adj, right, and my visited array. Now let us just write this function, void dfs. So have this. Now what I will do, I will do a visited of node, I will mark it as visited, that I have visited it. Then I'll call the dfs on its neighbor, so auto it adj of node, and if they are not visited, if visited of it, they are not visited, then I'll call the dfs on its neighbor, so it, and I'll pass adj as well as visited. Now and in the end, what I will be doing is I will be just returning the count, that will be the number of provinces, so return count. Now let us just run this. Okay, and now we will submit it. So as you can see, it is submitted. So thank you for watching the video, and make sure to hit that subscribe and like button, and I hope to see you all in the next one.